12 questions, all for your response. First one, we're going to find a standard normal probability, okay? I'm going to do it using the calculator. You could use your z-score table if you wanted to. If you like doing that, I'm going to do one like that, and then I'm going to go right from the calculator, okay? So if I wanted to find the probability that z is less than 1.35, I could go to my handy-dandy z table, and I could look for, not gonna work, 1.5, right? Is that it right there? 1.35, thank you. I go to 1.3, and then I look at 5, and that would be my answer right there, right? Whoops, except for that I circled the wrong foot. Sorry, it's this one. Ignore this one. 0.9115. I'll put that there. 0.9115. It's an approximation. Okay, let's do it with our calculators. So, I'm going to do that using my scratch pad, which is also good if you have an itch on your back. Get out the scratch pad. No? So, I'm going to get out my handy-dandy calculator, hit that scratch pad, and then I'm going to hit menu. Probability. I'm going to go distributions. And then I'm going to hit normal CDF. My lower bound is going to be that, right? Because let's look at the picture of it. What does my picture look like? Well, our normal distribution is like that, right? And our mean is right in the middle at 0. And we have a standard deviation of 1. So, I don't know, 1.35 is maybe like right about there. So what we're looking for is the area of this shaded region. Everything that is less than 1.35. So that means that my lower bound is like infinity, but we'll use negative 10 to the 99th, or the calculator has negative 9 times 10 to the 999th power. Yes.
This is just like the one.
Just exactly. There's no curveball. Well, maybe one. And then this is your upper bound. You've done this one almost. So then my upper bound is 1.35, and my mean is standard deviation of 1 because it is a standard normal distribution. And hey, I got the same thing that I got from my Z table, and that is real good. That's Let's do another one. No, back. Now we'll do this one. Probability that C is greater than 1.35. So my picture looks like this. Remember we said 1.35 is here, and everything greater is over yonder. So that means my upper bound is infinity, but we'll use 10 to the 99th power. My lower bound is right here at 1.35. Let's go ahead and put it into our handy-dandy calculator. What a machine it is. Alright, so we're going to go to our calculator. We're going to hit menu. Probability. Distribution. We go to normal CDF. And now our lower bound is 1.35. We change the upper bound to 10 So the 99 tower is big enough. And then mean and standard deviation are the same. You get 0.089 approximately, yes.
If it's asked for above in any question, would you have to the 90?
Yes. As your upper bound. 0.09. Sorry. Darn it. Okay. All right, let's do this one. So, what does this picture look like? Does not look like my mom.
I'm kidding. Oh, you want to talk about yeah.
All right, so that's what we're looking for, the area of that shaded region. So now, this is my lower bound, this is my upper bound. Let's put it into the calculator machine. Alright, so on my calculator, I hit menu, probability, distributions, and now I'll go normal CDF, and now what's going to change? The lower bound is negative 1.35. The upper bound is 1.35. Nothing else changes. It's going to spit out an answer for us. That answer is approximately 0.823. Okay, here we go. Last one that's like this. Alright, so what about this one? What if I want to find this probability? What does it look like? It looks a lot like the previous one, except that I'm going to shade some different regions. So I've got negative 1.35, 1.35. So I'm looking for the area of the shaded region. Now, when you're doing this one, the easiest way to approach it is to recognize that these two areas are the same, right? So if I find this area, all I gotta do is multiply it by 2, right? There's 2 of them. They're exactly the same. So this is gonna be equal to 2 times, how about the probability that Z is greater than 1.35? Because we calculated that already, right? What was that probability? 0.089. So this is going to be 2 times 0.089, which turns out to be 1.70. Okay, so the other situation that you'll run across on this test is you'll be told, hey, you have a normal distribution. The mean is 75. The standard deviation is 2. Calculate the probability that x is between 64 and 78, or something like that, right? Same type of situation, except for now, in this picture, your mean is no longer 0. Your mean is the mean that you've been given. So 64 is probably somewhere way over here.
Yeah.
78 maybe like there. So what you're being asked for is the area of this shaded region. So what I'll do is go to my handy dandy calculator and do some calculating.
Hey,
The
it's
power of
good.
Shinobi.
Real quick, can you look up who the supporters or Smith is, please?
For ninja references, thank you.
I'm correcting the calendar right now. You told me I was on hold, so I'm correcting the calendar and sending out invites as we speak.
Alright, so let's go to the calculator. Menu, probability, distribution, normal CDF. My lower bound is, what did I say, 64? Upper bound is 78.
That's not good.
Mean, I said was 75, thank you. Standard deviation of 2, right? So I get that is approximately 0.933.
Yes.
Expect that finding a probability below an x value is fair game, and finding a probability above an x value is also. But I feel like we're going to get enough practice with it, so I don't need a bunch of examples. Precursor into what we're going to start doing. So let's go ahead and move on to the next thing,
Who?
which is an actual problem.
Oh, shoot.
So a radar unit
Is he's on what?
is used to measure speeds of cars on motorway.
Okay, cool. So
Speeds are
actually
normally
lined up, so
distributed with a
perfect.
mean of
Let
90
it-
kilometers per hour
Thanks.
and a standard deviation of 10 kilometers per hour. What is the probability that a car picked at random is traveling more than 100 kilometers per hour? So in other words, since it's normally distributed, the distribution looks approximately like this, with our mean in the middle here at 90, and a hundo is somewhere right around here, right? Probability that it's more is going to be the same as the area of this shaded region. I know. I feel like either somebody just got jacked or.
Some just got robbed.
Okay. So I can find this by putting in my calculator normal CDF 100, my upper bound. My lower bound 10 to the 99th. Sorry, lower bound, upper bound. Mean is 90. Standard deviation is 10. Let's put that into our handy dandy calculator. It's an approximate answer. And get the answer. Alright, go into the calculator. Normal CDF. So we said 100. Upper bound was 10 to the 99th. Mean was 90, standard deviation of 10. We get approximately 0.159. So So I mean, if we were going to put that in context, we would say like around 16% of cars, or there's a 16% chance that a car picked at random will be traveling more than 100 kilometers per hour. Now on this next one, if we selected 100 cars randomly, how many would we expect at a speed of less than 98 kilometers per hour? All right. Well, first of all, we'd like to find the probability that we would select a car that has a speed of less than 98 kilometers per hour, right? And we can multiply that times 100, and it'll give us the number of cars, or the percentage of cars. We'll get a percentage, multiply it, that'll give us a number. So that's the plan. So first of all, we know that our mean is the same. But since we're going to randomly select cars, now we got a new number, right? We got that n is 100, which means that our standard deviation is going to change. We're going to have to calculate, remember that's your standard deviation divided by the square root of your sample size, which in this case is 10 divided by the square root of 100. All right. This is 1, right? 10 divided by 10. So now what I'm looking for is, I'll put normal CDF. We're saying a speed less than 98 kilometers per hour. So now my lower bound will be 10 to the 99th, or negative infinity. My upper bound is 98. Mean is 100. Standard deviation now will be 1, right? I'm just going to go ahead and draw the picture of what we're finding with that normal CDF function. So our mean is 100. We're looking at 98. So we're looking at the area of this shader. Yeah. Darn it. Thanks. That changes the picture. Thank you. 90. So 98's over yonder. So we're actually looking for this. Thanks. That means that I need to change this is 2. There it is, though. Watch it up. Not a mystery anymore. Alright, so let's look at what this is. Our lower bound is now that, right? That's good for a lower bound. We can use that. Our upper bound is 98. Mean is 90. Now the standard deviation is 1. And it's pretty certain. Oh yeah, because we're 8 standard deviations above the mean. So, so all of them, you would expect all of them to be going that speed. I don't know why. All right, so just continue. So that's approximately 1. So you would say all of them. But let's actually look at something a little more useful. Let's look at the probability that it is less than 89 miles per hour, okay? So if we're being asked for the probability that it was less than 89, then we're going to be looking at this. Sorry, guys. I don't know what happened with this problem. 90, 89, somewhere here. So we're looking for this, which means that we can perform the same calculation. I can just copy this, change this one to 89. And then I would get approximately 0.159. Oh, it's not the same as probability of 90. So if we did 89 instead, we would get approximately 0.159. Okay. If I wanted to know the number of cars, then what I would have to do is multiply 100 times 0.159, which turns out to be 15.9, or 16 cars. Okay? Yeah, you could just, it's really easy to change it to, I'll say, so there's another example. Alrighty, hey, how fast does the car need to be going faster than 90% of the cars? So this is the one where we would have to solve. I'll also show you another method of doing it just using your calculator, alright? So, in order to do this, I need the formula z equals x minus my mean divided by my standard deviation, okay? Which means that I need a z-score that corresponds to an area of 0.9. So if I'm going to use my handy-dandy table, I'm going to go to my table and find 0.9. So if I go to my table, inside the closest value that I can find to 0.9 is 8.8997. So that corresponds to a z-score of 1.28. Okay, 1.28. So that's what I'm going to use now. And here I'm going to say 1.28 is my z-score I'm going to use. So now I can write this equation. 1.28 equals x minus my mean, which was 90, divided by my standard deviation was 10, right? So if I'm going to solve this for x, I need to get this 10 to go away. How do I do that? Multiply both sides by 10. That gives me 12.8 here equals x minus 90. Why? Because those cancel. I'm going to add 90 to both sides. I get 102.8 kilometers per hour is x. Now I'm going to show you a way to do this just using your calculator as well. We're going to use the inverse normal. Okay? So I'm going to hit this. I'm going to hit the menu, the same place. I'm going to go to the exact same place. Probability, distributions, and now instead of doing the normal CDF, I'm going to go inverse normal. The area that it asked me for was 0.90, right? That's what we were finding? Or 0.9. Mean was 90. Standard deviation of 10. We got the same answer. So two different ways to approach that question, okay? If you We're not having fun with the algebra of 30. I always have it. 0.9. All right. Yes. 102.8 works. All right. So the next type of problem you're going to encounter is going to be using your normal distribution to approximate a binomial setting. All right? So this is indeed a binomial setting. The first thing you're going to be asked is, hey, does this work? Can you use a normal approximation to on this binomial setting? And when you're being asked that, what you're being asked is, can you, is this true? And is that true? All right, so in this case, what is P? P, 0.78, okay? Huh? Yeah, N would be 120. So then let's check it out. Is 120 times 0.78 greater than or equal to 5? Yeah, it is. How about 120 times, remember Q is 1 minus P, so that's 0.22. Another way to think of this is 22% of 120 more than 5? For sure. Alright, now that I know this, right, so that would be like part 1. Part 2, what's the mean and standard deviation? Well, the mean is the same as P, which is 0.78. And my standard deviation, remember, is the square root of N times P times Q, which in this case is 120 times 0.78 times 0.22, which turns out to be square root of 20.592, which is approximately 4.54. Alright, the probability that more than 99 pass the first attempt, now we can use our normal distribution, right? So in order to calculate that for part 3, we can just go normal CDF. My lower bound, we want more than 99, so my lower bound is 99. My upper bound is something like infinity. My mean we'll put as 0.78. And my standard deviation will be sorry, I'm running out of room. 4.5. My bad. We don't want to put the. No, we're good. No, we want to express this as a proportion. 99. And that's it. That's everything that's on your test.